Dear students, in the set chapter, the next subunit is intervals as subsets of R. So today we will see that different types of intervals. So for that, let A and B, small a, small b, belongs to R and A is less than B. Then the set of real numbers y such that y is greater than a less than b is called an open interval. So we call this as a open interval and is denoted by a b. What is the meaning of this one? All the points between A and B belong to the open interval A, B. But A, B themselves do not belong to the interval. So if you take 2, 5, this is the open interval. We call it as the open interval, and all the numbers in between 2 and 5. In this interval, which numbers lies? All the real numbers in between 2 and 5, excluding 2 and 5. So 2 and 5 does not belong to this interval. So we say that all the real numbers between 2 and 5. When I am using the word between, it means excluding 2 and 5. We can write excluding 2 and 5. Suppose, for example, if you take natural numbers between, for example, if I take the interval 5 to 10 and only the natural numbers, suppose if it belongs. So what are the natural numbers here? 6, 7, 8, 9. So this is the open interval. What is that open interval? Open interval is the set of real numbers in between 5 and 10. So here all the real numbers in between 5 and 10 excluding 5 and 10. So this is the open interval. In set builder form, same this open interval. In set builder form, how we write? Set builder form. So we write this one as x such that x belongs to R. I told you that all real numbers, comma, x is greater than 5 and less than 10. This is the set builder form of the open interval 5, 10. So suppose if you take another example, 2, 7. So what is the set builder form of this one? The set builder form of this is x such that x belongs to R, comma, x is greater than 2 and less than 7. So how to read that also see properly. X such that, two dots means it is such that x belongs to R. That means what type of number x is? X is a real number. And what is the condition, limitation of that real number? It's not all real numbers. The real number greater than 2. And here also double inequality. This is called double inequality. And whenever you read, you have to start from the middle. Don't say 2 less than x less than 7. It is x start from the middle, x greater than 2 and less than 7. So once again, x such that x belongs to R, comma, x is greater than 2 and less than 7. So this is called the set builder form and this is called as a roster form. So when you write in the bracket form, that is the roster form. When you write in this form, it is called as a set builder form. So first type of interval is, that is open interval. This open interval, if you represent on a number line, how we take? For example, if you consider 5, 7. So on a number line, we represent it as, this is a real number line. We will take here 0, 1, 2, 3, 4, 5, 6, you can extend it, 7, 8. Here if you take minus 1, minus 2, minus 3, these are the numbers. So 5, here it is 5. So but here it is an open interval. Open interval means what? We have to take here open circle, sorry, not here, 5, take a open circle, and 7, take a open circle. Means what? Excluding 5 and 7, all the numbers are there in between 5 and 7. So this is the representation of a in open interval on a number line. Or we can write in this way also. Just you take a open circle here, 5, this is open circle 7, and open circle means excluding this is, and all the numbers in between this you can just dark it. So this, what it means, all the numbers lying between 5 and 7, open circle represents excluding 5 and 7. This is about the open circle, open interval. Now the next type of interval is second interval, is that is called as a closed interval. Now what is that closed interval? The interval which contains the endpoints also. The endpoints also is called closed interval. Is called closed interval and is denoted by this symbol. So we use a big bracket here. So closed interval means what? It is the, here we include this end numbers also, endpoints also. So what is the set builder form of this one? A comma B can be taken as x such that x belongs to R, comma, x is greater than or equal to A and less than or equal to B. This is the set builder form of closed interval. Once again, this is a closed interval. Closed interval, whenever you read, you have to read in this way also. Closed interval A comma B. That means including A and B. And this is the set builder form. We call it as a set builder form. So for example, if I take 5 comma 9, closed interval 5 comma 9, that means all real numbers in between 5 and 9 and including 5 and 9. So what is the set builder form of this one? X such that x belongs to R and x is greater than or equal to 5, less than equal to 9. This is the set builder form of this one. And we call it this one as a roster form, and writing in this way it is called as a set builder form. Now how to represent on a real number line? You can take here 5 and here if you take 9, positive number. Now here it is included. Whenever it is included, you have to take a dark circle. Open circle means excluded. Dark circle means included. So this is again 9 is also included, and all the numbers in between, all the real numbers in between 5 and 9, including 5 and 9 is the closed interval. So this is the representation on a real line. And this is the roster form. This one is called as a set builder form. And closed interval means what? The interval which contains the endpoints also is called closed interval and is denoted by this symbol. So this is, whenever you find like this, it means it is a closed interval. All the numbers in between A and B and including A and B. The third type of interval is A comma B. Now observe here, the set builder form of this one is x such that x belongs to R x is greater than or equal to a and less than b. Now this interval is called as a semi-closed interval. Now what is the meaning of this one? Semi-closed interval. When first one is the closed here. So remember how to remember this one. If first bracket is big bracket, second is small bracket, so you name it as semi-closed interval. That means including a and excluding b. So when you draw a line, it is a and this one is suppose b. So including a means dark circle and excluding a means open circle, and all the numbers in between a and b. So all the real numbers in between a and b, including a and excluding b, is called as a semi-closed interval. So we name it as a semi-closed interval. So what it means is it is an interval from a to b, including a and excluding b. And the fourth and the last one is it is a comma b. This is the set builder form of this one is x such that x belongs to R, x is greater than a and less than equal to b. Means all the real numbers between a and b, excluding a and including b. So we call it as a semi-open interval. It is called as a semi-open interval. And if you represent it on a real line, it is a and b. Now here excluding a, excluding whenever you take, you have to take open circle. Including whenever you represent, you have to take a dark circle, and all the numbers lying in between a and b. So we call it as a semi-open interval. So these are the four types of intervals. So once again we will take one by one. The first example is it is if I take 5,11. What it means? It is what is the set builder form of this one? X such that x belongs to R, x is greater than 5 and less than 7. See the way I am reading. X such that x belongs to R, comma, x is greater than 5. First move in this direction. X is greater than 5 and less than 11. Second interval, and we call it as a open interval. So this is a open interval. Next one is it is 5,11 closed interval. We call it as a closed interval. What is the meaning of closed interval? All the real numbers which belongs to R, means that is a real number, x is greater than or equal to, including means equal to, and less than equal to 11. So both 5 and 11 is included. So we read it as x is greater than equal to 5 and less than equal to 11. Then third interval is, it is called as a semi-closed interval. It is semi-closed interval, and in this semi-closed interval, how we write in a set builder form? X such that x belongs to R, x is greater than or equal to 5. 5 is included. Sorry, here it is small bracket, and less than 11. So we call it as a semi-closed interval. This is the small bracket. And the last one is 5,11. And while reading also you have to read it as semi-closed interval. Semi-closed interval 5,11, semi-open interval. And the last one is semi-open interval. And this semi-open interval is x such that x belongs to R, x is greater than 5, excluding 5 and including 11. So these are the four different types of intervals. Remember how we name it, how we denote it, what is the roster form and what is the set builder form of this four intervals. Okay. The next point is, next one is complement of two sets. Complement of two sets or complement of sets. It's not two, you can say complement of two sets or complements of set. Now what is the meaning of complement of set? So for that we have to consider the universal set. So what is the universal set? It is the biggest set. It is denoted by this symbol. So let U be the universal, let U be the universal set and A be a subset of U. Then the complement of A is the set of all elements. A is the set of all elements of U which are not the elements of A, which are not the elements of A. Symbolically we write it as A dash, and while reading we have to read it as A complement only. Read it as A complement. Don't say it as A dash. So this is A complement. So what is the, if you consider let U be the universal set and A be a subset of U, the condition is here the set should be a subset of U. Then the complement of A is the set of all elements of U which are not the elements of A. In short, we can write it as A complement is equal to universal set minus A. This is what you wrote in sentence form. In short, we call it as A complement is equal to U minus A. Now, for example, if I consider U is equal to 1, 2, 3 up to 10 and A is equal to 3, 4, 5. See here, I told you the set A should be the subset of U. Now what is A complement? A complement means U minus A. So in U na ಇನ್ನೇನು elements ಐತಿ ಅದ್ರಾಗ ನೀವು A minus ಮಾಡ್ರಿ. So what are the elements in U? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ಐತಿ. ಅದ್ರಾಗ ನೀವು 3, 4, 5 cancel ಮಾಡ್ರಿ. 3, 4, 5 cancel ಮಾಡಿದ್ರೆ what remains here? 1, 2, 3, 4, 5 is there. 6, 7, 8, 9, 10. This is A complement. We'll take next example. Let A is equal to, if you consider AB, not A, we will consider let U is equal to A, B, C, D, E, F. And A is equal to, if you take A, C, E. So what is A complement? A complement is U minus A. That is, in U, you just cancel A, C, E. Minus A means remove it. So what remains? B, D, F. This is A complement. And if you take one more example, in this only B is equal to A, B, C. So what is B complement? It is U minus B, and that is in U you remove A, B, C. So remains what? D, E, F. This is B complement. Now we can represent this using the Venn diagram also. So what is the Venn diagram for A minus B, or Venn diagram for A complement? So for that, take a rectangle. I told you always this is nothing but universal set. So what is the universal set now here? A, B, C, D, E, F. In that A is there, so one circle only. What is that? A, C, E. So we have to find A complement. This circle is A, where the elements are A, C, E, and remaining U means what? All the elements. So A, C, E is already there. B, D, F. So now U means all the elements A, B, C, D, E, F, and A means A, C. Now what is A complement? B, D, F. So whatever you get the answer, that should be in the shaded region. So our A complement is, you have to shade all the parts except that circle. So this is A complement, and we write it as here somewhere A dash. So shaded region is A complement. Okay, for B, if you consider, this is universal. B is the set. What are the elements in B? A, B, C. Here D, E, F. Now what is the answer? D, E, F. So this is the answer. The shaded region is the B complement. So this is, you can write here down B complement, or in the shaded region somewhere you can write as B complement. Now in this complement there are few properties. Properties of complement of sets. Properties of complement of sets. Now what are the properties? The first property is A union A complement is always equal to U. Second is A intersection A complement is always equal to null set. Third property is A union B whole complement is equal to A complement intersection B complement, and if it is here intersection, A intersection B whole complement is A complement union B complement. These two laws are called De Morgan's law. We call it as a De Morgan's law. And fourth property is A complement whole complement is always equal to A. And fifth one is, and the last property is null complement. Null complement is always equal to U, and U complement is always equal to null set. So these are the properties of complement of sets. So we can verify this by taking examples. So in that the main is here De Morgan's law. A union B whole complement is A complement intersection B complement, and A intersection B whole complement is A complement union B complement. So these two are called De Morgan's law. Next is, we take examples. Now what are the examples? I will take few example. Let U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and A is equal to, it is 1, 2, 3, 4, B is equal to 2, 4, 6, 8. Our question is to find A union B whole complement. This is the first one, and the second one is B minus C whole complement. So what is the first question? A union B whole complement. So students, first bracket is there, so first solve the bracket. I will take the bracket, that is A union B. So first I will solve A union B. What is A union B? You know that all the elements of A you have to write 1, 2, 3, 4. All the elements of B you have to write without repetition. So 2 already over, 4 over, 6 and 8. So this is A union B. Now what is our question? A union B whole complement is equal to, what is the definition of complement? U minus A union B. So U is what? It is from 1, 2, 3 up to 9, minus, you have to minus in that 1, 2, 3, 4, 6, 8. So when you minus these elements, what you get the answer? 5, 6 is there, 7, 8 is there, 9. So when you subtract these elements, you will get the answer as 5, 7, 9. This is A union B whole complement. In this only the second question is B minus C. So I will take B minus C. B minus C means the elements which are present in B but not in C. So for that I will take one more set. C is equal to 3, 4, 5, 6. 3, 4, 5, 6. So what is B minus C? The elements which are present in B but not in C. That is 2, 4 is present in C also, 6 is present in C also, and 8. So what is B minus C? 2, 8. Now what is our question? B minus C whole complement. So this is U minus B minus C. In U, you just subtract B minus C. Means you have to remove that 2, 8. So you will get the answer 1, 3, 4, 5, 6, 7, 8 is there, 9. So this is B minus C. Observe that how to solve the problems. First A union B you have taken, then complement, and next example B minus C you first find it, then B minus C whole complement. Next example, if U is equal to, if U is equal to A, B, C, D, E, F, G, H, find the complement of A is equal to A, B, C, and find the complement of B, that is D, E, F, G. So what is A complement? It is U minus A. U naga A minus ಮಾಡಿಬಿಡ್ರಿ. So A, B, C minus ಮಾಡಿದ್ರೆ D, E, F, G, H. This is A complement. And B complement ಅಂದ್ರೆ ಏನು? U naga B minus ಮಾಡ್ರಿ. U naga B elements remove ಮಾಡಿಬಿಡ್ರಿ. So D, E, F, G we have to remove. D, E, F, G. Answer is A, B, C. D, E, F, G if you remove remains H. This is A complement, B complement. Next example. Draw appropriate Venn diagram. Draw appropriate Venn diagram for each of the following. So here first we have to just draw the Venn diagram. So first one is A union B whole complement. Students, remember that A union B whole complement is equal to A complement intersection B complement. So I am taking the Venn diagram for this one. Consider the universal set always represented in a rectangular form. Then A and B are the two sets. So whenever you consider two sets or three sets, always take intersecting sets. So this is A and this set is B. You can write up also A, B. Now A union B means what? This is A union B. If you shade both the circles including the common part, this is A union B. We need here A union B whole complement. So what is the meaning of A union B whole complement? U minus A union B. So U is the total rectangle. In that A union B if you subtract, that means what? This shaded region. This is A union B. This A union B if you subtract, what remains? A, this is the shaded part, excluding that both the circles. Don't include both the circles. This is called A union B whole complement. So this is A union B whole complement. Now students, remember, if you get the question to draw the Venn diagram for A complement intersection B complement, so here you will get a little bit confusion. So remember that A intersection A complement intersection B complement, this is always equal to this one, A union B whole complement. So both are equal. So therefore their Venn diagrams are also equal. So when you get the diagram to draw the Venn diagram of A complement intersection B complement, you say that it is equal to A union B whole complement, and you draw the Venn diagram which is equal to this only. So this is the Venn diagram for both A union B whole complement and A complement intersection B complement. Next one, same question. Draw the Venn diagram for A intersection B whole complement. This is the second question. We have to draw the Venn diagram for this one. So again we have to consider the universal set which is always represented in a rectangle. This whole is the universal set. Two sets are there, A, B. So I'll take A, B here. Now intersection means this is the intersection part. See here, this whole if you shade, this much part is the intersection. part. So what is the meaning of this one? U minus A intersection B means U naga total rectangle naga ಇದು common reason ಅಷ್ಟೇ ಬಿಟ್ಬಿಡ್ರಿ, ಉಳ್ಕಿದೆಲ್ಲ answers. So therefore the whole answer excluding that common reason which is A intersection B. So just shade in one direction only. So this is the excluding this part. ಇದೆಷ್ಟು ಪಾರ್ಟ್ ಬಿಟ್ಟು ನೀವು ಉಳ್ಕಿದೇನು ಶೇಡ್ ಮಾಡ್ತೀರಲ್ಲ, that is called A intersection B. This is A intersection B whole complement. Again same way students, if you get the question to draw the Venn diagram of A complement union B complement, remember this is equal to A intersection B whole complement. So which is the diagram for that is equal to this one. So when you get the question to draw the Venn diagram of A complement union B complement, you draw the same Venn diagram. So this is also the Venn diagram for A complement union B complement. So these two are very important. If you get a question to draw the Venn diagram of A complement union B complement, remember that is equal to A intersection B complement and draw the same diagram. And if you get A intersection B whole complement, this is a way, that is U minus A intersection B. Now next example, if U is equal to, we can take the questions based on intervals only. I have explained you about the intervals. So we'll take 2-3 examples on how to express it in a set builder form and interval form. So write the following as intervals. Write the following as intervals. First one is x such that x belongs to R minus x is greater than minus 4 less than equal to 6. So I have explained you how to write in interval form. So the interval form of this one is, now see here, it is only greater than. It is only greater than. Whenever you get a sign greater than or less than, it is always open small bracket you have to take. And here it is less than or equal to means including 6. Whenever including means you have to take a big bracket. So this is what type of, this is the interval form of the set builder form and we call it as a semi-open interval. Next example, x such that x belongs to R, 3 is greater than equal to minus 3, x is greater than equal to minus 3 and less than equal to 4. So what is the interval form of this one? See here now. It is greater than and equal to also. Greater than or less equal to. So including minus 3 and 4. So your answer is closed interval minus 3 comma 4. We call it as a closed interval. Next question is, write in set builder form. Write in set builder form. So how you write in set builder form? If you consider 6 comma 12, this is the semi-open interval. Semi-open interval set builder form, x such that x belongs to R, it is always a real number only. X is 6 is excluding, so excluding means only greater than 6 and including 12 means less than equal to 12. One more example, if you take, it is minus 23 comma 5, semi closed interval, x such that x belongs to R, x is greater than or equal to minus 23 including minus 23 and excluding 5. ಯಾವಾಗ excluding ಇರ್ತೈತಿ ಅವಾಗ less than or greater than ಅಷ್ಟೇ ಇರ್ತೈತಿ. including ಇದ್ದಾಗ less than equal to or greater than equal to symbol. The next is, I'll give few assignment examples. So today what we have completed about the intervals of sets, which there are 4 intervals, and then about the complement of sets. So complement of sets, we have taken properties and complements, examples on the complement of sets. So I'll give few properties. I have given here 5 properties. So out of that I will just tell you to prove that properties. So for that, the first question is, if U is equal to A, B, C, D, E, F, G, H. A is equal to, I'll take A, B, C, D, and B is equal to B, D, F, H. So first question is, in that, find A intersection B whole complement. Second, A minus B whole complement. Third, A complement whole complement. And fourth, find A union A complement. You have to find A union A complement. And fifth one is A intersection A complement. See, students, whenever you have a bracket, so here first, in first question, first you find A intersection B, then take U minus A intersection B. Here also first find A minus B, then take U minus A minus B whole complement. Here first find A complement. What you get the answer, take again the complement of that. And here first find A complement, then take A union. A is already there. Answer of A complement, take the union of that. And here first find A complement, next step you take A intersection A complement. So try to solve these examples and the examples given in the textbook. In the next period I will take what are the applications of, that is practical problems on union and intersection of two sets, which is the last part of this set chapter. So here we have completed about the complements of sets and intervals. If you have any doubt, you can ask me. Thank you.